Today, inshallah, we're going to start a new topic. I decided actually that we're going to go with PACS because actually networking is a little bit far away from, not far away, like not very much related to medical informatics. It's a tool for medical informatics. So basically, it's better to just keep going with the medical informatics stuff and basically have the networking part like in the later part of the course. So what we're going to talk about is picture archiving and communication system, which is a very much one of the most important medical informatics softwares or information technology systems that you can find in any hospital, basically. It's very much a key element of radiology at at this time, because basically now we have most of the radiology equipment are now digital. And basically, instead of looking at films, doctors are now looking at monitors to see the images and basically making the diagnosis based on that. So as a definition, PACS, or Picture Archiving Communication System, consists of digital acquisition, display workstations, and storage devices interconnected through an intricate network. So basically, we have four components. We have acquisition of images from the imaging modalities. We're talking about, of course, imaging modalities. Basically, we're not talking about any other devices like ECG or anything like that. We're just concerned now with imaging. The second element is display workstation. So basically, there are workstations instead of film lamps, basically as doctors used to use before, where they just hang the film and light a lamp and basically look at the film and make the diagnosis, using that film. Now we have, instead of that, we have display workstations, and they have very specific, requirements. It's not like any computer can do that. It's not like that. We're going to see that this is not the case. And the third element is storage devices. So basically, you're going to store all the cases instead of having the films filed in the EHR of the patient. Basically, we're going to have all the images in a storage device. Any question? Any question? Can you turn off the mic, please? Okay. For those of you who have a mic on, I think Sultan, can you turn off the mic? Okay, thank you. I think there's a problem in his connection. Anyway, so the third element is storage. And this storage actually is huge. It's very different from EHR. EHR has some information, but actually, basically, the information contained in EHR that we talked about before, it's mainly related to the report that the doctor wrote about this patient from the images. So usually, when the doctor writes a report, it doesn't include all the images. Here we have all the images. And if you know how medical imaging modalities work these days, usually for MRI, for CT, for things like that, we are now collecting volumes. We're not collecting single images. So usually you end up with hundreds of megabytes for each patient. So basically, it's a huge amount of data. In the report that goes to the EHR, the doctor might select a few images and write a report, and basically just to demonstrate exactly how he got to that diagnosis, and that's it, okay? He doesn't include all the images. Here, for the PACS, we store everything, and it's a requirement, basically. You have to store everything so that if there is a problem or is a conflict somehow, or basically a complaint from a patient, something like that, or a misdiagnosis, something like that, you can go back and look at the full data set. So the storage devices here are huge. Basically, the largest you can see in any of the different imaging softwares that you're going to see in a hospital. Of course, you have to interconnect all of these. Digital acquisition, you are actually connecting to medical imaging modalities like this. And you have basically, you have radiology workstation for display. So this is display. This is acquisition. Here you have storage. Okay, you have to connect all of these actually through the network. Okay, usually basically you have a server that actually connects all of them, but you have to have a very good network that would allow everybody to be connected together. Okay, you have to have also interface with other information systems. We're going to talk about such system as RIS, Radiology Information System, which is a subset of HIS, which is Hospital Information System. Basically, this interface is very important, and all of these actually basically are usually part of the EHR of the patient. So they connect to the EHR of the patient, and they get the information of the patient, and basically sometimes you get the information of the patient here in the archive server so that you can save it with the archive, and sometimes you actually have some data from here, like the report, you can actually send it to the Radiology Information System. We're going to talk about the RIS in the next topic, inshallah, but this interface is very important. So for example, if the patient, if the physician that was basically that was seen by the patient, basically asked the patient to go and do an ultrasound imaging. Okay, so basically he must actually enter a request through the basically the HIS that this patient has to do this kind of examination. Okay, this request actually goes to the RIS, and basically the scheduling of the patient goes through the RIS, and basically this is sent to the archive server so that when you acquire the data, you can actually link that request to the acquired data and basically save them in the archive. So basically this thing is very important. Usually the radiology information system doesn't contain images, it just contains administrative information, it contains exactly the purpose of this examination requested, it has the appointment, it has the scheduling of the different machines, basically, how different machines are scheduled to work on patients, things of that sort. We're going to talk about also something called web server. Basically, you can actually have, just as you have doctors working inside the hospital, you might have actually doctors working from the outside. So if you have a consultant, for example, imagine that you have a hospital, not in Jeddah, maybe in a very small city, okay, in Saudi Arabia. And this small city is far away from any other major city in the kingdom, okay? It's very difficult to imagine that you're going to have all specialties of radiology working in that hospital, in that small city, okay? It's a small hospital in a small city, okay? So sometimes you have general radiologists who can actually diagnose the simple cases, but if you have a very specialized case, if you really need a specialist or a consultant, then you might actually send the data through a web server to a consultant in a major hospital somewhere else, and basically use his expertise to diagnose the case and basically send the report back to that small hospital. So basically, you might have a connection to a web server that would allow actually doctors to be working from remote areas, from remote sites. Okay, so basically the PACS system is a very what I should say about it, it's basically very detailed system. It's very complicated system. It's very important system. Right now, all radiology departments are relying on such technology to basically make the work in a radiology department basically more efficient, basically the more organized, the ability to collect the data or basically retrieve the older data is much easier. Imagine that you are working in a hospital that doesn't have PACS. Then basically, if you have an EHR for a patient, you might not have the original film, basically, or sometimes you have the hard copy of the film. You don't have a digital form of the film. And basically, in order for you to retrieve the film from his file, it's sometimes, it can be really a very bad experience because it might take some time to find it. And basically, when you actually get it, you can actually use it. And then on the way back, it might get lost. When it gets lost, it's very difficult to find it. So it's very difficult, okay? So it's extremely very important. It's extremely important technology for the efficiency and proper operation of a radiology department. So basically, we can think about PACS as an electronic version of the radiologist reading room and the file room, okay? The reading room basically is where the doctor is sitting, used to sit before in front of a lamp, and basically he would post the film in front of the lamp and basically light it so that he can see the radiograph and make the diagnosis out of that. The file room is basically after he finishes diagnosing the film, he basically sends the film to the file room so it can be filed, so that when he needs it in the future, he can look it up and basically retrieve it and basically check it against the current film, for example. If he wants to see if there is any improvement or any deterioration or anything like that, he would like to see the current film against the film that was taken like a year ago or something. So basically, he has to have both films and compare them together. So basically, this used to be in hard copy. You use films. Now you use basically digital form of everything, so that you can retrieve things much more easily and basically much more effectively and basically securely as well. One of the very important things that you have to talk about when you talk about any medical informatics system is what's called workflow. Workflow is the processes that happen in a hospital for a certain operation or a certain procedure that happens in a hospital, okay? So for example, basically for someone to go and get a radiograph or basically undergo an X-ray examination in a hospital, basically, if you're talking about a film-based workflow, you have to basically request that particular film. Basically, you basically go and ask for that particular examination. You have a referral from a doctor and go to the front desk, and basically you basically ask to have an appointment to make a radiological scan. Okay. Then after that, basically they would have the order and basically take it to the radiologist. Basically, this order. Basically, takes the order from here or the receipt from here and goes to the radiologist, who actually takes him to the radiology room and basically makes the examination. And then he would get the film and process it, because the films have to be processed. They are not really basically like old time where you actually have to process the film like with chemicals so that you can get the actual film after exposure here. And then you check it if it's okay or not. After it's processed, if it's okay, you can go ahead and use, or basically send it to the doctors and basically do the interpretation of the films. They have like a big lamp like this, and they post the radiographs there, and basically sit in front of these lamps and write their reports. Okay, so sometimes they write their reports by hand, or sometimes they basically write it on a computer and print it out. And basically, after that, they give it to the doctor or basically leave it in the front desk so that the patient would pick it up from there. Right now, with PACS-based workflow, you're trying to basically minimize the changes that happen to the workflow, because usually this workflow has been going on for maybe tens of years, basically. It's been like this for a lot of time, basically a long time. And usually in a healthcare facility, whenever you change the way things are done, sometimes you face resistance. Sometimes there are so many errors because people are confused. Basically, they don't know exactly what to do, things of that sort. So basically here, all you do basically, all you change is that basically instead of using a regular X-ray machine, you basically use a digital X-ray system here. Okay. And basically, when you have a digital X-ray system, basically you have like an image receptor, and this image receptor actually is in digital form. So basically, this image processing actually just basically put the image receptor here, and it's converted to digital form and sent directly to the computers or the workstations where the doctors reside. So they look at the images on the computer screen and make the diagnosis and basically write the report, and that's it. So basically, the only changes you see here is that there is no film, basically. You're filmless now. So basically, this is filmless workflow, okay, without film. So basically, the communication here is through the network. Everything's through the network now, okay? And also, for now, also actually, even remove that part where you actually take a receipt or take a piece of paper to the technologist. Actually, once you sit here, you have a digital request sent. So basically, when you go to the radiology department, you will find yourself there. You'll find your appointment there. So you don't have to hand in any paperwork. So basically, it's filmless and paperless also, meaning that the transcribed report is also in a digital form. Okay, so basically here you have papers here, you have papers here, you have a report written here, you have the film, you have actual film basically here, and basically after, of course, after you do that, you have to actually file the film. You take the film and put it in the file room so that whenever you want it again, you probably can basically retrieve it from there. So the term workflow is a term that can be used in any industry in general. So basically, when I tell you about registration, course registration, basically you have something called workflow of registration, course registration. You have certain steps that you have to go through so that you can register for a particular term. Okay, so basically you can also have a process for anywhere. Basically, if you talk about basically, if you're going to buy a car, for example, there is a workflow that any car dealership would make you go through so that you can get a car, you can buy a car. Okay, so basic workflow can apply to any industry. Okay, and it describes how a process is done, usually step by step. Okay, in radiology in particular, workflow describes how the examination is done from the order entry, this is the first step, to transcribe report, this is the last step. With PACS, it is possible that the time it takes from performing the examination to completing the final radiologist report is only a couple of hours, compared with a couple of days for the film-based workflow. So basically, this is very important. When you actually shorten this cycle, it might not be a clear actually, because the steps here are very similar to the steps here. But actually, the processing, the film processing here, and the fact that you have to wait until it's processed, this actually takes time, and you have to wait for the film to be dried, and then you have to take it and give it to the doctor here so that he can look at it. So basically, these things that would actually involve people doing things and basically physically moving the film from one place to another and basically putting them here, and you might put it somewhere where the doctor doesn't see it, so basically can get delayed a little bit. So basically, usually here you're talking about a couple of days, a day or two, basically. Here you're talking about much less time, okay? So basically here, because everything is digital, once you actually perform the exam, the image is basically available to the doctor almost immediately. So basically, you can right away, you can actually do this interpretation very quickly. One other reason for the couple of days here, if you need a specialist to interpret the films, okay, if you have a very specialized problem, or basically if the doctor, if the current radiologist, if the radiologist that is resident or presently available in the hospital suspects something that he is not sure of, he needs a second opinion, okay? Then he might wait for his colleague to come maybe next day, okay? Here, for PACS-based system, he can actually send the images to his colleague at home to look at and basically make the interpretation and basically confirm whether this is, the thing that he suspected or basically nothing. So basically, he can make that determination very quickly. If that radiologist is not the one who can diagnose this, basically you have to wait for someone who might be a consultant who comes maybe 1 day a week or something like that. So basically it can be delayed much further for the consultant to come. Here, actually, you can send it to the consultant anywhere, anytime. If it's urgent, then you can actually get a diagnosis from the consultant almost in a few hours. So basically it's much more efficient here. So it's not a matter of just going digital without, even thinking about why. Okay, it's very important to realize that it's much more efficient when you do that. It's much faster. It's much basically because you're not using films, you're not using paper. Basically, you're more environmentally friendly. Okay, and by the way, the chemicals that are used to process the films are hazardous materials. So basically, when you are done with the chemicals that are used for film processing here, you cannot just throw them in the toilet or something like that. You can't do that. You have to actually dispose of them in a very specific way so that you don't harm the environment. So basically, when you are using films, when you are using chemicals that are used in the film processing, you're basically your environmental footprint is much larger, it's much heavier. Basically, you're causing more problems to the environment. Basically, here it's definitely much more efficient. Are you clear on the definition of workflow? Okay. Workflow, by the way, in any medical informatics system, you have to basically think about workflow. And basically, the first thing if you are working in a hospital and you're proposing a certain medical informatics software like PACS, like HIS, like RIS, or whatever, the first thing you will be asked about is how workflow will be affected. Because workflow is basically, it's everything to a hospital, basically. If your system will make the workflow easier, smoother, faster, then your software will be very much welcomed. If it requires some additional training, if it requires some additional delays for people to adapt, or might be confusing such that it might actually not be as efficient or as fast as it's supposed to be, then it would be rejected by everyone. Of course, the usual example I give in such things is that back home in my country, basically, when the traffic police actually changed their system to digital, instead of having to, when they issue the driver's licenses and things of that, so when you renew your driver's license, instead of getting your file in a paper form, they actually move to a digital platform so that you have everything in a digital way, in a digital form. So basically, everybody thought it would be much more effective, much more efficient. And the problem is, whenever you go, instead of waiting for your file to be found, or basically suffering from your file being lost, now you're faced with a problem that the network is down. So basically, you go everywhere, you go every day, for example, and they tell you that the system is down and we cannot do anything for you. So basically, when you have a digital system that defies the purpose, when you basically, when the problem becomes the digital system not working, then people will basically reject the solution that you're offering them. It's even more so in a hospital, because basically in a hospital, healthcare professionals are usually, they worry much about the safety of their patients. So if you have a system that would delay a service that should be given to a patient, they will be mad at you. They will be really, really unhappy. Okay, so basically, you don't want to do that. Okay, and basically, it's logically, it shouldn't be like that. Okay, so basically, whenever you think about a particular solution, you have to think about workflow and how it will be affected. If there is a learning period at the beginning for everybody to basically get into gear and basically learn how the new system works, and after that it will be working smoothly, you have to actually prepare them, at least psychologically, for the learning curve, and basic for the initial bumps, through the road, and basically after that you promise them that it will be much smoother. Okay, but this is really important. In general, if you want to think about how to do or how to implement a PACS system, usually you have two system architectures. What's called client-server system and what's called distributed system. Basically, in a hospital, usually in a big hospital, okay, you're not going to have a single imaging system. You're going to have many imaging systems, actually. Okay, you might have like 20, 30, 50 even imaging systems in a single hospital, basically. If you go to the King Abdulaziz University Hospital, basically only in the dental department, we have almost about 20 systems. Okay, and if you go to the imaging or the radiology department in the Faculty of Medicine, they probably have like 60 or 70 imaging systems. So you have a lot of imaging systems. How are you going to connect these imaging systems? These are the acquisitions or acquisition systems, basically. And how are you going to have all of these systems connected to the archive and to the reading rooms? Basically, you have computer, you have three components, as we said. You have acquisition, you have storage, and you have display. Okay, and usually you have a server that would basically link these things together. You have a server somewhere. Okay, so basically this links these things together. So are you going to have these are the modalities, these are the imaging systems. So are you going to have the server in the middle? So basically everything is like client server. So basically the acquisition would actually finish acquiring the images and send to the server to pick them up and put them in the storage. And then when the display, when the doctor is here, he wants to see a certain study or a certain, radiology scan from a particular acquisition system, he would contact the server, and the server would see where it was placed in the storage and basically retrieves it and puts it back to the display or what. Basically, it can be like this. This is called client-server systems. Basically, a server is in the middle somehow, and basically you have all the acquisition systems sending their data to the server that stores them in the storage, in the central storage. And then the doctors are here. These are the reading rooms, basically. They contact the same server to collect the data from there, okay? So basically, every reading room has access to any one of these modalities, okay? The other system, which is called distributed system, you have a very different architecture, actually. You have a server, definitely, but this server actually is like for archiving, basically. The individual imaging systems, you might actually have certain reading rooms. Okay, so basically this is a display room or a reading room here. Okay, here. You probably have this one assigned to be CT only. So basically you have a reading room for CT only, or this particular workstation is dedicated to CT. So basically this might be connected directly to the CT systems, CT scanners, so that you can collect the data directly from the CT scanners. You might have other workstations that work with MRI, that work only for MRI, okay? So basically these are connected directly to the MRI systems. So basically it's different when you have systems like this. So basically instead of going to the server to collect the data, they collect it directly from the imaging systems, and basically it's collected here. And basically if this one here needs to have the same data, it communicates with this to collect it through this one here. So basically the imaging systems are connected to dedicated workstations that work only for these particular modalities. And basically if you have another one, then this will communicate with the other ones working on the same modality. So basically this goes on for each one of the different systems. And when they are done, they basically save the data to the archive, so that if you need it later, then you can retrieve from the archive. So basically for a new case, you will retrieve it directly from the imaging systems. If you're talking about an old case, then you will get it from here, from the archive, okay? So this, instead of having the server in the middle here, no, you have the server also in the middle, but actually it's not involved in all the communications. You have individual links here that would make this actually definitely much faster, because you're basically connected directly to the CT system here, and here connected directly to MRI, here connected to ultrasound, and so on. If you look at these architectures, we're going to talk about them in detail in just a second, but just from that particular overview, you can see that you're going to have a network problem here. You have definitely one of the definitions of a PACS that you have to have a network that connects all of them together. The server here will have huge traffic. Regardless of you acquiring or displaying or whatever you're doing there, basically the server is involved. So basically the network connections to the server must be done in a, must be extremely fast. And basically you have to design it in a way that would avoid congestion. Otherwise, it's going to be a problem. Okay. Here, it's definitely much faster because the connections here are direct. But the thing is, if you look at the architecture here, any reading room can read any imaging modality. So from this reading room, for example, you can basically look at any one of these modalities. Basically, you can look at any data set from any one of these images. Okay, you can look at MRI, you can look at CT, you can look at ultrasound, regardless of the modality, you can read it from any one of these reading rooms. Here, these two are dedicated to CT. You cannot read anything but CT. Here, MRI, basically, you cannot read anything but MRI there. So basically, these are dedicated to the new cases coming from CT. You can retrieve all cases from any modality, but actually, the new cases are coming only from CT. So basically, you cannot use, if you have many cases for CT and no cases for MRI, for example, you will be waiting on these to finish so that you do more cases while these are empty. Basically, they're not used. So basically, you can see that there are some some advantages and disadvantages. You have to have trade-offs. Here, the network requirements are much less, but actually you have inefficiency in the form of having workstations dedicated to particular imaging modalities. If you are not counting the number of cases or preparing or planning ahead for the number of cases expected, you might actually end up having congestion on some of these network or some of these workstations, like many cases here that are waiting to be diagnosed, while other workstations are not basically utilized at all. Okay. So basically, if we want to define architecture, the word architecture, system architecture can be defined as the hardware and software infrastructure of PACS. So basically, how we're going to actually reconstruct the PACS system in the site, okay, on site. So it includes the acquisition devices, the storage, display workstations, and the image management system, basically, and definitely the network actually that supports all of them. Let's talk about these architectures in more details. So if you talk about client-server based systems, images sent directly to the archive server after acquisition and are centrally located. So basically, once the acquisition occurs, all the data will be sent directly to the archive so that they can be stored in the central storage of all images. Display workstation work as clients of archive server and can access images based on centralized work list. So basically, for the doctors to work, so basically you have, say, for example, 10 workstations, 10 reading workstations, and you have 10 doctors. These doctors actually are tasked, and basically in that central server, you can task each one of these workstations with a certain list of studies that each doctor has to work on, okay? So basically, if you do that, this is much more effective because basically you have, for example, you have 100 studies that were done today, for example, okay? You have to make diagnosis for all of them. So basically, if you have 10 doctors, you assign each one of them 10 of these studies, okay? So this is done centrally through the archive server. The healthcare worker at display workstation chooses the name from a central list. So basically, he has a list, and basically, whenever the particular patient is selected, the archive server would send the image to the display station. So basically, he say that I'm going to start with patient number 5, for example. Okay. So basically, at the workstation, he doesn't have the data. But once he selected that patient, the archive server would send that workstation all the images, all the study images for this particular patient, so that he can get started on this study to diagnose it. Okay. After client is finished, after the workstation is done, the image data are flushed from the memory. So basically, you're getting a copy. You're not getting the actual data. This is very important. So basically, what the archive server will send the workstation is not going to move the data from the storage to that workstation. He's just going to copy it from there to the workstation. So basically, after the doctor finishes, basically the study is still there on the client workstation. Basically, once the client is closed, once the doctor wrote the report and closed that client, basically the data set associated with that particular patient would just be deleted from there. Okay, flushed from memory is just deleted. You don't care about it because you have another copy in the archive server. In that workstation, most systems actually would allow basic image manipulation at client workstation, display workstation, or client can change and changes can be saved on the archive server. So basically you can make some changes. You can basically, for example, if you have a certain image and you do some image enhancement or do some annotation meaning that you wrote something on the image. So basically the image is like this for ultrasound image, for example. You would come basically and put some measures here and write some stuff here. He can actually save a copy of this, okay, on the archive server. He's not gonna override the old one. He's gonna save a copy of the new one, the one that was manipulated by the doctor, because basically it's a part of the diagnostic process. So basically it's good to save it because it's a record of how the diagnosis was made. So basically he can do that. The advantage of a system like this is that any examination sent to PACS is available anywhere without other interventions. So basically, any workstation can access any study, which is very convenient. So basically, your workstations are utilized almost uniformly. You don't have any, if you have, for example, many cases in CT, then most of the workstation can work on CT. If you have, next day, you have more cases in MRI, then most of the same workstation will be working on MRI. So basically, you can adapt the same number of workstations to basically deal with the kind of flow in any one of them without any problems. One very important thing actually is that only one person can open a study to read it, while others will receive message that this study is open and being read. Meaning that, because actually it's a central server, you can imagine situations in very large hospitals where actually two people can actually open the same patient. If this happens, then basically two doctors will write two different reports on the same case, while other cases are not diagnosed, which is not very effective, not very efficient. So here it's like when you access a certain patient, basically you're the only one working in that patient. So basically it doesn't allow anybody, it doesn't allow two people to work on the same case. So this is very effective because as I told you before, it's very important to divide the studies between the doctors, okay, in order for you to be able to finish all the cases. So basically, if you don't do that, you might actually be repeating all the doctors are working on one case, and then all the other cases are not diagnosed. So this is not the right way to do things. Another very important advantage is that all studies are available with the new one on the archive server and can be accessed from all workstations. This is very important. So basically, from any workstation, you can access any new study, and you can also access from, because actually the archive server has all the data, the new and the old ones. So you can access the old and the new one on any workstation, which is very effective. Doctors sometimes, if they suspect something in the images, they would sometimes look at the medical file of this patient. They would look if they have another study that was done by the same patient before, for example, last year or the year before, something like that, so that he can compare whatever he sees, or basically if he has certain suspicions, or basically if a woman had a mammogram, for example, and there were some signs that were suspicious, and basically he would like to see how they looked before and how they look now, and basically detect whether it's going in the right direction or basically becoming worse, okay? So basically, sometimes it's very important to look at studies from different time points, the old ones with the new ones, and basically here it's the ideal situation where the same server or the same workstation can access both from the same server. So basically, all of these are very good advantages, actually. And actually, I would like to say that this is probably the most commonly used architecture, because usually these advantages are, are basically very much overweigh any other disadvantages. The disadvantages is that the archive itself is seen as a single point of failure. What is the meaning of that? It means that if the archive for any reason goes down, then the entire system is down. Okay, so basically, this is basically every single modality is connected to that archive server. Okay, every single workstation is connected to that archive server. If anything happens and this archive server needs maintenance, needs repair or anything like that, because basically physical damage can happen, and sometimes software upgrades must be done with the server down. So basically, in this case, everything will be just, you have to stop everything. So this is definitely a disadvantage. Now we have other architectures where you have multiple servers that can alternate. Basically, you can actually have a backup server, and usually this is a very good idea in critical systems like this, so that you can basically, if one goes down, basically the other one will take over and nothing is affected. But if it's a single server, then this would be definitely a disadvantage. The other thing which is very important, system is very much network dependent. Basically, you have very large volumes of images. You're talking about, maybe for each patient you have maybe I'm not exaggerating, but probably we're talking about gigabytes of data. Okay, so basically it's huge amounts of data. Okay, and usually when you have that much data, you usually have of course, you have multiple sources of data, and you have many workstations retrieving the data for different patients from different time points, even from old cases and new cases and things of that sort. So basically, the network performance is critical here. So the whole system actually is dependent on the network performance to perform well. Okay, so basically the kind of networks used here must be carefully designed. Okay, so basically if the network is working properly, then the system will go just fine, will actually work very well. Otherwise, if you have any network problems, then you might have problems, and basically the network would slow down everything with it. The last disadvantage is that the archive server handles many requests at once and can become bottlenecked from high volume of requests. So basically, the archive retrieves data from the different modalities. So basically, he's requested to move the data from the modalities to the storage. At the same time, he's receiving the same server is receiving requests from workstations to move data from the storage to the workstation. So basically, sometimes you have many requests coming at the same time. So basically, it can be bottleneck. The server would be a bottleneck in this case. But basically, if you have a proper design and you have actually multiple archive servers, they are working together. Basically, you might actually be able to solve this problem. And basically, there are some very neat designs actually that would allow you to do that. Okay, so basically, you might have multiple archive servers, but to the modalities and to the workstation, they still look like one. They still look like one server. They actually have load balancing or load distribution between them so that you can effectively basically handle many requests and basically don't have a bottleneck. So basically, of course, if you want to solve these kinds of problems at the network, and the reliability and the the ability to handle many requests, the cost of the system would be a little bit more expensive because you have to duplicate things, you have to design things with high-end equipment rather than regular equipment. So basically, all these disadvantages are not technical. They are definitely technical, but actually, in order to solve them, there are solutions. what I mean is that there are solutions, but they are expensive. So basically, if you want to have system that doesn't have a problem from the point of view of reliability, of the network slowing down, or the bottleneck of in handling requests, you have to actually buy a very or basically put together a server that would not be cheap. Basically, it would be very expensive. Now we're going to talk about the distributed systems, the other type of system that we talked about. Basically, the acquisition modalities send images to designated reading stations. Designated reading stations meaning that I have reading stations that are basically for CT, you have a certain workstation designated for CT. Another is designated for MRI, and so on. Okay, so basically, reading and review station, they are very much the same, basically. In some systems, images are sent from modality to archive server, and the archive server distributes images to designated workstations. But actually, it's not like that here, basically. Sometimes it's actually, the designations here are basically the regular thing is that you have the acquisition directly send the reading, the data to the reading station rather than the archive. So basically, this is an exception, actually. Okay, if you do it like this, then you're closer to the client server. Okay, so basically this may happen in some cases, in some modalities, but not all of them. Okay, so basically, in order for it to be a distributed system, you have to have the connections, most of the connections between the modalities and the workstations, not the server. The problem you're going to have here is that the designations of the reading stations must be based on radiologist's reading preferences and extensive workflow observations. Meaning that if you have, for example, you have 10 reading stations, how are you going to distribute them between imaging modalities, for example, MRI, CT, ultrasound? How are you going to divide them? Are you going to divide them equally? I don't think it's a good idea to do it like this. Okay. First of all, you have to make sure that the workflow you have is observed, meaning that if you have for each day, for example, you're going to have 100 cases of CT and only 10 cases MRI and probably 200 cases of ultrasound, then you have to divide them to take into account that. So probably you're going to have only one MRI, you're probably going to have maybe 3 here and probably 6 here. Okay, so that you can take into account the how these systems are going to be, or basically how these cases are going to be handled. Okay, and it's not enough actually to have the number of cases. Sometimes for CT cases, for example, the time to do the diagnosis is much longer than ultrasound, for example. So basically, this doesn't work like this, because basically, if you have 100 cases here, they might take maybe 300 work hours, for example, man hours. Here, for 200 cases, probably for each one of them, you're probably going to take a half an hour to diagnose them. So basically, it's like 100 man hours. Okay, so basically, here you need more workstations because you actually, the doctors will be spending more time here. They need more time here. So basically, you have to observe the workflow. You have to observe the flow of patients. You have to observe how many cases in each modality you're receiving every day on the average. You have to see exactly the average time that you would need to diagnose each one of these cases on the average, so that you can actually properly assign the workstations to the different imaging modalities. If you don't do that, then it's going to be a big problem. Okay, if you do them right, then you work actually much better than the client server. But the problem is it's usually very difficult to predict how the workflow will be, and basically it's usually not sustainable. Sometimes you have many cases of certain modalities, sometimes you have others. So basically the variations would make some congestion in some workstations and some basically lack of utilization for others. So basically, this is usually one of the key elements or one of the key problems that you're going to face with distributed systems. So in addition to having the acquisition modalities link directly to the workstations, the workstations can still basically, I told you after the images are diagnosed, they are not discarded. They are actually sent to the server to be basically stored there. Okay, so basically, instead of the modality sending the data directly to the server, they send it to the workstation. So the copy on the workstation is the only copy on the system until it is diagnosed, and then it's sent to the storage server to be saved there. Okay, so the same workstation can query and retrieve images from the archive, and they store them locally, basically. Okay, so basically, if the same patient, if you have a current study, and you need to see the older studies that you had for the same patient, you can actually retrieve that old study from the archive server. Okay, so you have the new one from the acquisition modality directly, and you have the old one from the archive server. After you finish, the new one should be saved in the archive server, and the old one that you had from the archive server, you can just delete it. Okay, so basically kind of tricky. Basically, you have to make sure that you're saving the new ones to the archive server, so that it basically, because this is the only copy, and the old one, if you basically keep them on the workstation, it will fill up the hard disk, and you will not be able to retrieve other studies. So basically, you have to regularly delete them so that they can basically free up some space to basically retrieve some more studies. So basically, the advantages of the distributed system, if the archive goes down, then the local reading at the workstation is not interrupted. So basically, the only problem is that you're not going to be able to do that. So basically, this is the only one that you cannot do. But the new studies is still going to go just fine. Do doctors need historic images or the history of the patient for every study? No, not really. It's basically, sometimes they need it, but actually in many cases, usually they don't need it. Okay, so basically, if the archive is on maintenance, for example, or it has a problem, then the acquisition will still go on. The data will be saved on the workstations until the server goes back up, and basically it is stored there after the diagnosis is made. So the diagnosis is not dependent on the server, like in the client server model. Because images are distributed to many locations at once, it is less likely that PACS data will be lost. So here you have data on the acquisition modality, you have data on the workstation, and then it is saved eventually in the archive server. Okay, so this is kind of I'm not really I'm not really a big fan of this statement, because basically the fact that the data will be lost is not as easy in current systems, basically. So for example, when the acquisition modality sends the data to the archive server in the client server model, or to the workstation here in the distributed system, it doesn't delete the studies from its memory, basically. It still has storage on its own. And basically, it still keeps a copy, at least until the hard disk is basically fills up. So basically, the data is still saved at least in two places, in the client server or the distributed system, basically. So basically, I don't think the data loss will not be that much of a problem in either here or there. So basically, I don't think this is a real advantage, to be honest, because the client server is also very secure as far as the data is concerned. The more important, so basically this is not as, I don't think it's a real advantage, basically. It's probably not very much different from what happens in the client server. Here, this is a real advantage because you're much less dependent on the network. Because for the server, the network connection to the server is very critical, because you have so many different connections and you have to handle them all at once. Okay, so basically you have maybe 100 or 150 very high-speed computers sending data or receiving data from the server. Okay, Each one of them is sending at the maximum speed. But unfortunately for the server, you're not going to be able to handle all these at once. Okay, at least if you have 20 of these, only 20 or only even 10 sending you data at the maximum speed, you're not going to be able to handle that. So basically, it's very much network dependent for the client server. Here, you're much less dependent because you have a direct connection between the workstation, the reading workstation for a particular modality, and the modality itself. So basically, the data can go much faster there because it's a dedicated connection. Nobody else uses that connection. So basically, the data transfer here is much faster, and you're not really, the network is not a bottleneck here. So this is definitely an advantage here. And also, this is another advantage, basically. The disadvantage is that you have very heavy reliance on the assumption that the distribution of images is being done correctly. Okay, meaning that basically if you have multiple workstations, okay, and basically how are you going to have a central work list for the doctors? Because basically these workstations are not connected to a central server, okay? So basically, for a particular modalities, basically you can pull the data from the original acquisition modality. You can pull the data from the MRI system, for example. It's not going to tell you, no, somebody else is reading that. He's not going to tell you that. The modality doesn't tell you that. If you're going to retrieve a certain case, it's going to give it to you and that's it, okay? There is no central server on the modality itself. So basically, two people might be actually working on the same data at the same time. So basically, each workstation has a different work list. It's not a central work list. And therefore, only one person, this is another thing, by the way, this is two working at the same time. For each workstation, you have a different work list, meaning that only one person can be working on that list at one time. So for example, if you have a CT workstation, okay, and you have multiple cases on that workstation, and you have two doctors, only one doctor can work on that workstation at any given time. You cannot open two cases at the same time because you have only one workstation for CT, which is a big problem. Sometimes it's inconvenient to read additional studies that may be designated for another workstation. So basically, sometimes doctors ask for the patient to do an ultrasound and MRI, for example, or an ultrasound and a CT, okay, at the same time, basically, the same patient. So the radiologist, if he wants to diagnose that patient from these two studies, he might have a problem doing that. Because basically images that come from the CT system are designated for workstation 1. Images coming from the ultrasound system are designated for workstation 8. He cannot access the ultrasound system from workstation 1. So basically he has to physically go to workstation after he finishes the CT diagnosis in workstation 1. He has to go to workstation 8 so that he can look at the ultrasound image. He cannot look at both at the same time, which is a problem. Sometimes it can be a problem. So this is definitely something that is disadvantageous here. Okay, and the thing that I was talking about here, actually, two radiologists can read the same examination because you don't have a central server. You don't have, when you have a central server, you know exactly who is doing what. You have access to all the reading workstations. You know exactly what each one is requesting. You're sending the data for each one of them. You're sending the studies or the patient files to each one of them. So you know exactly who is doing what. If somebody is trying to do something that somebody else is doing, you will tell him that. There is somebody working on that case on workstation 5, for example, okay? Here, you have no control because basically the retrieval of the cases is direct from the modalities themselves. You don't have a central server that would supervise the allocation of cases to doctors. So basically, this is one thing that is definitely, that might be a disadvantage if you have a very large hospital. If you have if you have a small hospital and you have a single room for all the doctors, then basically the doctors can ask among themselves, is anybody working on this case? They can know, but actually in a large hospital, you have multiple reading rooms. Doctors might not even know each other. You have many doctors. So basically, sometimes it's very difficult to confirm that this case is not diagnosed by or being diagnosed by somebody else at the same time. So basically, as you see, most of the with any engineering solution, you have a trade-off. Usually, you have advantages and you have disadvantages at the same time. So basically, you have to choose a system that would basically best fit the kind of workflow and the kind of radiology department that you might have in your hospital, for example. Any questions? Okay. There is another, it's not really a third type, but maybe you can think about it as a subclass of a client server. Okay. It's basically, it's essentially a client server system, but you add to that a web server. Basically, you have another web server added to the archive server. This web server would allow the data to be available on the internet so that you can actually not only share the data with workstations, reading workstations inside the hospital, you might actually share it with other workstations in remote areas. This is actually very cool. When you have, for example, in the US, you have Cleveland Clinic, one of the very large hospitals in the US, or Mayo Clinic. Okay, they have different branches. You have different locations, basically, and they are all connected together. So basically, when they are connected together, you might have doctors working depending on the kind of workflow or kind of workload that they might have at a certain time. Doctors from another branch might be working on data from the other branch. So basically, this would connect to the other branches. Sometimes, if it's a small hospital, then this would be connected to a consultant. Basically, they hire a consultant and they send him the difficult cases, or basically send them the diagnostic reports from the young doctors or the residents, so that they can confirm it, basically. So basically, having a web server would allow the connections, instead of just having the connections inside the hospital with the hospital network only. No, you have another connection to an outside the location, and basically this connection is used to basically add more diagnostic services to the existing services. Okay. So basically, it's exactly the same as client-server systems in the data flow. The significant difference here is that both images and application software for client display are held centrally at the archive web server. So basically, sometimes the web server here might have the workstation software, so that when you log in, you basically, through a regular browser, it would allow you through that browser to basically be as if you are sitting in the reading room, basically. So basically, this is very effective, because basically sometimes the application softwares are very expensive, the applications that the doctors use to diagnose their images. So basically, it might be a very good idea to have it like this, so that they can work on it without having to buy a personal license, basically. So basically, they are working through the hospital license for that software, for example. Okay. So basically, in a client-server system, client has an application software locally, and only images are sometimes at archive server. So basically, for the client server, basically, because you are inside the hospital, basically, if you have a reading station inside the hospital, you can install that software inside the hospital. But basically, when you have a hospital license, you're not allowed to give that license to somebody who is remotely working. For example, a consultant who is not affiliated with the hospital. It's just somebody you pay him for just services, but he's not affiliated with the hospital. So you cannot, basically, because of the license is very expensive, basically, if you give him a license, he would use it for other things, not just for yours. So you allow him to only work on the application software you have through that web server. Okay, so basically the main difference between the web server accessing the images from the web server is that the application is there. So if you log in from any computer outside, you're basically gonna see the software only on the web server. You're not gonna have a local copy of the software. Okay, for the local reading stations, they have the software installed. So the advantage here is that the client hardware can be anything that supports appropriate web browsers. So basically, imagine that you're working with a data set that is hundreds of megabytes, okay? Very large, okay? Usually, basically, you actually, it can be maybe much more than gigabytes even, okay? It depends on the kind of image that you have. And usually for regular studies now, as I told you, you acquire volumes. So basically, if you're going to process such volumes, basically, if you want to do visualization, for example, then you have to have a very strong or a very powerful computer to do that. If you're working through the web server, you're just basically as if you're working on a computer inside here. So basically, the software is running here. It's not running on the computer of the consultant. So all you need basically for the consultant is to have just a computer with a browser. So basically, it's just a display computer. It doesn't require any particular hardware with extra capabilities that would allow the kind of processing to occur there. So basically, it offers great flexibility with hardware, but the disadvantages is that the displays may not be able to support the diagnostic quality. If you're sending images through the browser, usually the quality of image display through browsers is a little bit less than the actual software. So this might be a little bit of a problem, okay? Basically, the same application is used on-site and at home in teleradiology situation. We're going to talk about teleradiology in, basically there's one topic actually about teleradiology, when you actually have sometimes the diagnostic model is based on consultants. Basically, you don't have any doctors on, on site. Basically, they send everything to remote consultants and they do everything. So this is teleradiology, basically. If you do that, basically, if you're using a web-based system, basically the same application that is used on site and at home. So basically, if the doctor is on vacation, for example, he can access the system from wherever he is. If he's needed in an urgent situation, something like that, he can access the web server and from any computer. It doesn't have to be a strong computer or powerful computer, and he can see the same interface that he sees in the reading room. The disadvantages include the functionality may be limited because the software is not installed locally. Basically, you're working through a web browser, so basically, regardless of how things are done, basically, you're dependent on the internet connection speed, for example, okay? So sometimes there is a delay, sometimes some of the functionalities might not actually be available on the web server, they might be available only locally, so it depends on the kind of things that you're talking about. But actually, in general, there might be some limitations on some functionalities on the web server in comparison to the ones that are on the local workstations. Of course, the bandwidth of network connection limits the amount of data that can be transmitted for download, and some programs are too large to be transmitted over available installed networks. So basically, this is a problem of the internet speed. When we were talking about the internet dependency in the client-server model, we were talking about local area network. We're talking about the Ethernet inside the hospital itself, or the Wi-Fi. Now we're actually talking about the internet speed, which is much less actually than the Ethernet that you have locally. So basically, it's very common now to have gigabit Ethernet, okay? It's not common to have gigabit internet, basically. Basically, if you have a connection of 100 mega or 200 mega, that would be great, actually. The current speed at my computer here at the university is never above 50 mega, for example, okay? So the internet connection is usually much less, much slower than the Ethernet. So basically, this bandwidth can limit some functionalities of basically, when you are retrieving data or sending data or whatever, it might be a little bit of a limitation there. Definitely, as with the client server, the network is the biggest obstacle to performance, because actually here the web server is still communicating with the archive server through a network, through the local area network here. Okay, so if you have limitations here, you're going to have a performance limitation in your web server activity. So the client is accessing the software through the web server, but accessing the data through the archive server through the local area network. So if you have a problem or a congestion in the archive server, you're going to have the same problem here seen by the web server. Okay. Inshallah, next time we're going to talk about the display workstation. We're going to talk about the kind of monitors and kind of displays that are used for radiology. And we're going to talk about the other physical components or the other components of a PACS system, inshallah. Any questions? So inshallah, next time we're going to start at 6:40 as today, inshallah, so that we're gonna have more time. So if you need to delay it a little bit more, I'll be happy to do that also, because I know the time is very short. Any questions?
دكتور، هل في أنظمة صور يعني مفتوحة داتابيز مثلا تكون مفتوحة، أو لا هذه كلها تكون مغلقة حسب يعني
database for what? For what?
أنظمة صور اللي هو ال PACS.
PACS is intended to be private images for patients. So basically, these are parts of the patient data. You cannot have it as public. You have public databases for certain diseases, but they are basically what we call sanitized. Basically, you basically remove all the patient data, but these are not used for diagnosis in this case. They are already diagnosed, and basically you're using them as a teaching file, for example, or basically for research, but you have to remove all the data. But what we're talking about here is we talk about the data of patients that are yet to be diagnosed. So they contain all the information of the patient. So basically, you cannot share them publicly, definitely.
Hey.
If you need the database, if you're talking about research and you need the data, there are many locations actually that you can get all kinds of data actually.
دكتور، في مواقع معينة مثلا؟
Definitely, yes. Just send me an email or WhatsApp. I'll send you I'll send you one site. You'll find huge amounts of data there. Okay.
طيب تمام، جزاك الله خير.
Okay. One of many, by the way. There are many places where you can find data sets. Any other questions? Okay, so inshallah, I'll see you next time. Inshallah, next week, we're going to have a lecture on Sunday, and Tuesday is off because of the holiday, inshallah. Okay? So I'll see you, inshallah, on Sunday, inshallah. Thank you. Assalamu alaikum.